Alright, time for another DraftPhysics.com video presentation, debatephysics.com also, where there are over a dozen 5-minute videos on different ways you could experimentally dissect this distinction between momentum and kinetic energy. And what is pointed out is the evidence is quite murky, let's say. But the logic, I say, remains pretty consistent and irrefutable that momentum is the foundation of energy in the universe, and that the kinetic energy theory, this adding a 1/2 and a square to the velocity, is just crap, frankly. And they're just going to keep selling it. And so anyway, stupid comments on the website, blah blah blah. I think it's the silly person, whatever his name was, 3 names, Johnny Walker, yeah, little Johnny Walker. So let me constantly move the goalpost. I'm not moving the goalpost. I mean, obviously I pointed out before Ian made his video, what we're after is trying to figure out how much energy the spinning object has, or how much energy it takes to spin it. And yes, rolling doesn't work, just like rolling doesn't work for regular objects. Now, that's one of the 5-minute videos. It explains that friction isn't linear, that heavy things incur more friction and fast things incur less friction. Those two factors mean those are called variables. You have to understand the variables, but you refuse to do that. So you just keep shooting out of bounds and saying we scored a goal. I mean, if we're going to use analogies, and come up with new excuses. They're not excuses, they're called explanations. And it's an elemental and fundamental part of dissecting any failure that a system has. And clearly there's a failure for you to be able to produce results or consistency in your experiments. Again, you won't even show anything close to it taking 4 times the energy to go twice as fast, or 9 times the energy to go 3 times as fast, or 16 times the energy to go 4 times as fast, or 25 times the energy to go 5 times as fast. You have nothing indicating this has anything to do with reality. And it's directly what your theory says has to be the truth. Okay, and speculations in an attempt to fight reality. So again, I'm going to defend reality. You're going to be on the ash heap of shitty person who defended fables and crap. You're going to be on the ash heap of people who pretended to care about facts and science, but really were facts and science's biggest enemies. You're just going to be found out to be what you are, is faith-based religious kooks. Just advocating because you need it to be true. Surely one of these experiments will eventually prove me right. Well, surely these experiments will get done. Okay, surely someday they're actually going to do an experiment where they say, let's see how much fuel it actually takes. Let's see how much water pressure it takes to turn a turbine. Let's see how they're going to actually figure it out. And they'll figure out that, oh yeah, this kinetic energy thing doesn't have anything to do with reality. Because I must be right. Well, I'm just saying I must be right because, frankly, how could the truth be hidden for so long? I mean, you failed to reveal the truth in hundreds of years with playing with your theory. You failed to produce evidence. And that's supposed to make sense to somebody. Well, it really doesn't. It's the only thing that matters. Ya idiots. Whatever that even means. Clearly, the truth does matter. Clearly, I have no good reason to think I'm wrong. Because, frankly, you haven't touched any of the real arguments. I mean, Ian Gosling did the experiment with half the mass at twice the velocity and found that it compressed the clay exactly the same amount, which I could draw as a different example. But the idea that you think the half mass going twice as fast has 4 times the energy, where do you have an experiment showing that? Too stupid. So this is where he shows who he is, just because he's whatever. Ryan Gosling does an experiment where he debunks Goofy's lifelong pet peeve. How many people do you think are reading this? So, I mean, it's obviously a video I watched and played in my video. It's not a hidden video or something. And he doesn't prove anything. So, again, he doesn't debunk anything. Okay, where Goofy claims that V2 equals 2 times V1. Whatever the fuck that could mean to somebody. So you imply that there's a video and then you say something that nobody can understand what the fuck you're talking about. I mean, nobody could really understand what you're talking about here with this 2V. At 2:27 in the video, more pendulum lever collisions. Again, it's a video I played. All right, anyway. As predicted from conservation of angular momentum. So nothing like anything was shown or predicted. There was no, again, he did not calculate or in any way discern what the actual velocities were. And we certainly don't know if he's actually getting a good transfer because he's still got reflections. And again, he wouldn't do the simple thing I said, which is just move the weight in a little bit or take a little bit of the weight off and see what happens. 10%, because that's how much you're losing to the lever. So again, the truth and the real variables just couldn't make a dent in these religious kooks' faith. That's all there is here. So anyway, so we'll just draw some stuff. Make the argument. So as I pointed out, you can sort of, so this is one of these things that physics has never done, and so simple. And you're just like, whoa, how can all these years they overlook something this simple? Okay, I mean, so the idea is, you can put a scale, the regular way, or you can just do this with a scale, okay? You can put it sideways. And then you can just say, well, how fast do I have to push something, okay, an object, to make the scale read its weight, all right? And so I did the experiment, and it comes out 1 mile per hour, all right, conveniently. Okay, so 1 mile an hour. I move any object 1 mile an hour, I'll read its actual weight. I mean, its weight in gravity. Because I'll be duplicating what gravity's doing when you're just sitting somewhere. It's essentially moving you 1 mile an hour. That's what it's, it turns out that way. And if I want to double it, if I put you on a scale and then I move you 1 mile an hour, okay, plus I drop you from 1 centimeter, I will double that weight. So at 1 centimeter, I'll be falling at 1 mile an hour, okay, and I already have the weight of 1 mile an hour. So essentially, okay, it comes out to 2 miles an hour, but I'm just saying, that's how easy it is. So I can double your weight just by dropping you 1 centimeter. And then I go 4 centimeters and I'll double that again. Gravity. That's how it works. So nobody's done it. No one's documented this simple truth. Okay, and I claim it's a truth. I mean, certainly no one's come close to proving it not to be the truth. So we don't have anything like that. We should try to do this, I suppose, to get a flatter screen here. I should try to do this right. Yes, that's what I should try to do. All right. So I'll get rid of that. And yeah, that's probably close enough to enough of the screen. So I just have to figure out where to write. All right. So the other thing I've talked about the hydraulic thing, but I mean it's a pretty good example of how to think about this. So what if I have a hydraulic cylinder and I put a constant amount of pressure, from a constant hunk of weight? All I have to do is I poke a different size hole. I poke a big hole, all right, then the velocity, and so if I make a big hole and a small hole, the velocity will be twice as much, right, depending on the size of the hole. So I'll have twice the velocity here, but I'll have half the amount of mass moving. So there'll be half the amount of mass moving, but it's twice the velocity. And this will be 1 velocity and twice the mass. Okay, so we'll use this terminology. So it's a simple enough experiment, right? I mean, you can't get much simpler. So the argument is I'm going to lose the same volume per minute here. So over time, I'm losing the same volume, same amount of water. This water is going twice as fast, through half as big a hole. The pressure will decline at exactly the same rate. And so if I just did the two separate experiments, right, one and then I did the other, the volume will decrease at exactly the same rate. And you're actually going to believe that the smaller I make this hole, I can double and then triple and then quadruple some sort of thing called energy. So the energy of what's happening here, which is fixed, it'll be exactly the same for both circumstances. Okay, so let's draw another tank, because you're really dumb. So we have to make it really clear. So we got a big hole over here, no hole here. All right, now we put a little hole in here. Okay, small hole. It's still in the picture, right? Yes. Okay, so fluid's coming out twice as fast here, coming out half the velocity there. These two experiments, this will be exactly the same. This will behave exactly the same. This will fall at the same rate for both objects. The pressure will be exactly the same in terms of how it's relieved. And you're saying just this fact means I have twice the energy here. Twice the kinetic energy. Now obviously by momentum, that's not true. Momentum says, no, everything's just fine. We have the same momentum leaving the cylinder. Same thing, no problem. And yes, it's true that water under higher velocity can do more damage to a surface. But if you wanted to, it's the difference between you want to knock down a house. Okay, you need a lot of water to knock the house down. Now you want to bore a hole in it, you could use this jet of water at a high velocity, a small number of atoms at a high velocity, and you could bore a hole in it. But if you want to knock it down, you need the volume, you need the mass. So it's I've made the point that you people really believe that 1,000 atoms, all right, going 1 mile an hour is not the same. It's 1,000 times weaker than one atom going 1,000 miles an hour. So if I have one atom going 1,000 miles an hour, I'm more likely to knock something over or do something than if I have 1,000 atoms going 1 mile an hour. So if I turn those into people, do you really think so? It's just going to deliver the energy differently. This will deliver the energy very quickly. Okay, when it hits the surface, there'll be a lot of action really fast, and this will do it slowly. In the sense, it's a lot of action, but it's over a great deal of surface, and it's going to take, well, in this case, time wouldn't be a factor, I guess. But yeah, the slow velocity means each object is hitting it, so all the subsequent, if it was pins being knocked down, you could obviously understand that this one's going to knock them down quicker, but it's not going to knock down more of them. You could sort of understand it by analogy. That if it was crashing into a bunch of dominoes or something that it could be knocked down, that this one's going to do it faster than this one, but that's it. It's going to do it in less time. It'll hit more stuff in less time, and this one will take longer for the hits to happen because it's happening more slowly for each object it hits. But it's the same thing. This is not 1,000 times more. I mean, that's a huge number, 1,000 times more energy. Come on. So it's like making the argument that you use 9 times the fuel, 9 times the gas to go 3 times as fast. It doesn't make any sense. It doesn't happen in real life. No car engine works that way. No motor controller works that way. The faster I make the motor go, I'm starting to use exponentially almost, quadratically more energy. For a lot of these systems, they get more efficient the faster you go. So there is awful lot of good reason, not to believe in kinetic energy as any kind of real thing. It just has to do with the fact that and I've used the space analogy again. It's and a physicist has conceded the space analogy. He's conceded that, oh well, in space, the speed of your projectile is not going to save you. It's not going to move the spaceship. Simple little experiment, and nothing from little Johnny Walker. I fire the gun, and I have the bullet. So I fire one circumstance, I let the gun fly out. The other circumstance, I let the bullet fly out. The bullet has 2,000 joules of kinetic energy. The gun just has 2 joules of kinetic energy. Those are the facts of their math. Okay, now momentum says they got the same energy. Momentum says there's exactly 100 here, let's say, and 100 here, and that's all there is. Alright, so momentum says this is the same energy, and momentum wins because the spaceship, as conceded by a physicist Michael anyway, keeps going straight. It doesn't see this 2,000, and it doesn't see this 2. It doesn't recognize that somehow I have put more energy into the universe going one way than I put into the universe going the other way. It doesn't turn the spaceship. So, again, you're saying, let's just ignore that fact. That's out of bounds. That's not real. No, it's a real thing. It's a real thing you have to account for. You have to explain how the ship does get turned against everything NASA teaches pretty much, or you have to explain why it doesn't. Because if your kinetic energy can't move the spaceship in space, the simplest experiment you could do, you got something in isolation, no gravitational fields to mess things up, no nonsense. You're just saying, here I released mass going a speed and mass going a speed, and what happens to the spaceship? Can't make it any simpler. If you can't move this matter, okay, throwing energy out, then your energy isn't energy. It isn't real. If it can't move mass in empty space, it's not real. Alright, so there are so many of these. Again, on the debatephysics.com website, there's a few of these in 5-minute forms explaining why it just doesn't fit. Alright, so let's go. Alright, I'll just continue. So let's explain. So we have the simple little pendulum type experiment we're trying to get done, where you put the 2 mass in here, okay, with a velocity of some kind, and the expectation is that twice the distance, okay, you can put a 1 mass and it'll come out with twice the velocity. This is twice the distance, so this has 1 velocity. Now that's the expectation from my side. That's conserving the momentum, which seems like a pretty important concept. Now they say the kinetic energy gets conserved, and this will only leave with 1.4 or 1.33, according to physicist Michael. And I would say prove it. So, but what we've observed, okay, is that this really is what you're trying to do is duplicate the Newton's cradle, because in this circumstance you can do uneven masses. The Newton's cradle won't do uneven masses. Uneven masses doesn't allow you to do the transferring. Now, if I put a mass over here, like I have explained, I could have a 1 mass crash in here. And if I put a 1 mass touching, this will fly off, okay, with the same energy, and it'll just keep going back and forth, and this will stay stationary. But if I just move this a tiny, tiny bit, just leave a little air gap there, okay, then all of a sudden that whole thing breaks down, and this ends up having more, if this is a 3 mass and these are 1s, this will end up having 150 momentums crashing into this. So in one circumstance it only gets 100. I use a little air gap, it gets 150. And we end up with a reflection. So this does move. So this will move, and with somehow a total of 150 is the assumption. true? I don't think so. But anyway, but the point is that the Newton's cradle can't do the conversions. Okay, so when big objects hit little objects or little objects hit big objects, Newton's cradles fail to transfer the energy, and that's where the lever comes in, because it can do the transfer. It can take, the Newton's cradle can't do the deceleration acceleration thing. This thing can only move at a speed, velocity, and it can only say to the other object, this is the velocity. It doesn't do conversion, so it can't slow down the interaction, so this can go at 1/3 the velocity. It can't do that conversion, right? You have a velocity going in. This simple system doesn't have enough time, but this creates just that little bit of time, and it creates this ability to transfer, okay, to do the conversion from a very slow action here with the heavier mass, slow velocity, into a high velocity here. Okay, in this case, twice the velocity. And that makes perfectly good sense, that you're going to move the half mass, the mass that weighs half as much, okay, twice as fast. And that's what this lever is going to do. And so the idea is you have to first account for how much the lever weighs, because you're going to have to move the lever with the mass you're moving. Now, as I pointed out, the catapult sort of fixes this problem. So if you just set up the same experiment, and instead of having a mass come in, you just have a catapult system. So you put a spring or a rubber band here, and you have a constant force. Then you can launch your 2 from here, and you can launch your 1 from here. Okay, and the fact is you won't have to account for the work the lever does, because both will be requiring the same work as by theory. And so the lever is going to do the same work. It's the same mass moving in both cases. It'll move exactly the same speed, okay, to launch the half mass as twice the velocity as it would the 2 mass at 1 velocity. Same exact motion in the lever. So you know that you've eliminated this problem of the weight of the lever. But anyway, back to this one. So that's what you got to consider, is the weight of the lever. And once you take that out, okay, then you can just say, well, if the lever uses 10% of the energy, then I know I got to make this 10% lighter. Okay, the mass has to be 10% lighter. Or I just move it in 10% the distance, and I'll fix the problem and get a maximum of 90% of the energy out of here and minimize the reflection here. So we want 0 reflection ideally. Ideally, if there's a reflection, your energy is not going into the object. Seems kind of obvious, but you know, that's what a reflection is indicating. The energy didn't go into the object. If something bounces off of a surface, well, you know, the energy didn't go into it. I mean, it always turns out that way. The other thing moves less. The more bounce back you get, the less the thing you hit moved. And the less bounce back you get, the more it moved. Duh. All right. So yeah, so you have to just account for the fact that there's this, you know, and the fact is this does have to, you know, if this does have a little bit of bending in it and springiness in it, that's going to slow down what has to be a very quick transfer. The transfer, the movement here has to be connected to the movement here in real time. And anything that slows that down, a little flexing and bending that takes time to get through the lever, will destroy the effectiveness of the experiment. So there's some subtleties to it. They're not dramatic subtleties, but they exist. Okay, you gotta account for the fact that the lever might not be rigid enough. You gotta account for the fact that the lever has a weight. Even in this experiment, you're going to have to make sure this thing is, you know, but see, at least in the catapult experiment, you can make the lever out of something really hard, because the weight of the lever won't matter. It's always going to steal the same amount of energy. So if I was to have a preference, this is the experiment to do. But anyway, so all this is the subject. They say they've decisively proven something, that they have some big compile of great fantastic evidence, and it all leads to this great conclusion, when no, it doesn't. And you know, he brought up the Ryan Gosling character. I mean, he did the experiment with, you know, just dropping the masses. So he dropped a half mass from 4 times the distance. Okay, 4 distance. And he, dropped the full mass from 1 distance. Okay, so this had twice the velocity, and this had 1 velocity, and he dropped them onto a clump of clay, a little cylinder of clay, and he got what I would have predicted as the solution, which was they both compressed the same amount. All right, indicating it's the same pressure, it's the same effect, it's the same energy. Now, he didn't show that experiment because it didn't, came out my way, and we can't, he can't, he has to move the goalpost to a different town. He has to move the experiment out of town. So nobody can see it because, seeing would be sort of believing, right? If you saw it and you said, yeah, gee, there's not a whole lot of, you can say that the clay is kind of rubbery, you can say lots of things about what's going on, but there really isn't much excuse for it to be exactly the same. So if he would have gotten a little bit off, maybe he would have showed it. But because it came out, exact, he didn't show it. And then they accuse me of, moving goalposts or changing the parameters of the experiment, when no, he did it my way. He did the experiment the way I suggested. See, the first time he did it, he miscalculated, so he got the results he wanted. He got clay that was compressed twice as much, and so because he did the experiment wrong. Okay, and then when he fixed it, he got my answer, okay, and didn't show it. And made a video basically saying, look, we have to move the goalpost because it came out his way, so something must be wrong. We got to find out, we got to make excuses. I mean, your hypocrisy here is just amazing. So why don't we just all concede that this should already be proven? None of these experiments should need to be done. You mean, what, I actually have to take some syringes and I have to push, with a syringe, and then I'll push into a tube that's twice the thickness and half the thickness, or I could just push another syringe, right? I could just have another syringes attached, and one of them's a big syringe and one of them's a small syringe, small cylinder, half the size the cylinder. This thing will move twice the velocity that this moves. Well, I say this has twice the energy. No, that would be ridiculous. It doesn't have twice the energy. It's half the volume moving twice the speed. Half the volume moving twice the speed is the same amount of energy. So, I mean, all these experiments should have already been done. And the fact that these bums and liars and creeps and shitbrains won't even admit that. In the 350-year history, I knew this one wasn't going to write. Yeah. Anyway, nothing. They've got nothing, okay, in terms of a record of experiments. And the ones they do have, the Chardonnay clay, that's on the draft, that's on the debatephysics.com. Well, it's on the draft physics thing. You hit the 5-minute video link and it'll show you the 5-minute videos. And there's one on clay, denting clay. And clearly, poor logic involved. Clearly, it's not a good way to detect energy. Just as rolling objects isn't a good way to detect energy, rolling them in friction. Now, I think those are irrefutable arguments. I've begged people to refute them. I've offered to pay them to refute them, and they won't do it. Those are the facts. There's no moving of goalposts. There's a simple statement here. Don't you think science had a responsibility to do one of these experiments at some point and do it well to establish a proof? I mean, the fact that they won't even concede that science has way underperformed in terms of fulfilling its obligation to provide the physical evidence. This isn't like a religious argument with the physical evidence. You have to go across the world and collect it and do a bunch of geology and do genetic tests and do all these complicated things to say prove evolution. This is so much more simple and mechanical, and they have failed to do any of it. I mean, look at the meticulousness of Darwin. I mean, collecting millions of shellfish, You know, I mean, he spent years on one subject of a snail somewhere, or this or that, documenting and document all of this. You know, they go to the different islands and see that the wildlife is more diverse, and things that are on the oldest island, you know, haven't gotten to the newer islands yet. Blah blah blah. You can tell the timeline, all the logic used. You know, discovering how volcanoes work and all the rest of that shit. And look what physics has done. Nothing. And they won't concede that's a fact. That the most important subject in physics is energy, and they have done no energy experiments. Nothing. Nothing elemental. Nothing fundamental. They've never rolled two objects and then calculated how much heat went into the surface they rolled it on. They've never done any of these experiments. It's a pathetic history of how to make a religion, not how to do science. How to do religion is what they've done. I think that's probably enough. I'll pause and think about it. All right, just for emphasis, because that kind of thing is probably necessary with you people, I think I will just do it one more time. You know, just the volume pressure argument, and you know, just so you understand what you're claiming, and just such a simple change in how I do an experiment. You claim makes this gigantic difference. All right, so again, we have two vessels that are going to be pressurized, okay, by a piston with a mass. All right, and so just draw the two. You can probably see that. Yeah, okay, you can see that. All right, and I'm just gonna put a big pipe coming out of this one and a half the diameter pipe coming out of this one. All right, so I might as well fill in the pipe so you get it. All right, and I'm going to get a flow of water. Obviously, this is going to go like this, and this is going to go like that. Okay, twice the velocity. So I have twice the velocity of this. So I have 1v here, 2v here. Now, by volume of water, I have the same volume of water. So the mass is the same. Same mass will come out of this nozzle that will come out of this nozzle. It's just going to come out faster here. And that's going to be the only difference. So this is going to fall at exactly the same rate. It's going to be the same amount of energy going in. You won't be able to miss that. This will just, you know, this will take 10 seconds or whatever. Let's say it takes 10 seconds for this to fall and hit the thing. Same amount of time. The water will be ejected at twice the velocity here that it's ejected here. And that's all you're going to see is the difference. You say this is 4 times the energy coming out here. Well, it's 2 times the energy. Oops. Ugh. Sloppy. Right, that means 2 times 1, and this is 1 times 1, so it's twice as much. Okay, twice as much the KE. Yeah, squared 4 is 4. Half of 4 is 2. Okay, so I had to think about it for a second. Anyway, so it's twice the energy. So I didn't do it. I have the same energy coming in. This is exactly the same energy on this side of the equation. And you're saying that somehow by having it open wide, I'm losing half the energy. So 1/2 the energy is lost by allowing the water to go out. And I somehow conserve more of the energy, right? So I can't make free energy, right? So all you can say is this: the smaller the hole I make, the more I conserve the energy. So if I make it 1/4, then I'll get 4 times is the energy. So you're going to say, well, yeah, this is less inefficient. So I'm still losing a substantial amount of energy. I don't get to conserve the energy until I make it as small as possible, I guess, and create the highest velocity fluid. And that's the only way I can conserve the energy. with the kinetic energy formula, because I'm automatically losing a ton of it if I don't do anything. So we're right back to, their silly, 5-ton train, and I add 5 tons to it. I drop another 5 tons on it. So it's 5 here, 5 ounces, 5 pounds, doesn't matter. And I end up with a 10 that has 1/2 the KE. And we know that experiment. That one's been done. And we know, too, that it's just a mathematical necessity every single time. You'll never do an experiment where you have a mass and you double its mass and you don't have its energy. You don't lose half the energy. So no matter how graceful you connect these two things together, somehow half the energy just disappears. Come on. You gotta know better than that. You gotta know you can't do that to energy. You can't make it, you can't destroy it. So why are you pretending this is viable physics? Shit. Alright, so we'll call that enough. And move on to other things and such. So, till the next time, blah, 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 blah.